Welcome to Spring LIB.
So we're asked for the percentage change in the momentum of a proton as it accelerates from certain speeds to certain higher speeds, right? So really the only equation you need to know here is the momentum equation for special relativity, which is 26-4. And this is that P equals gamma mv, okay? Or mv over square root 1 minus v squared over c squared. Okay, m being the mass of the proton, v being the velocity at which it moves. Okay, so what we can do first is compute all the different momenta for the different speeds, right? So let's start with v equals 0.45 c. Let's call it p sub 0.45. That will be m sub p for the mass of the proton. Let's leave everything in terms of mass of the proton and speed of light c. That'll make our calculations easier. Okay, times velocity. Here it's 0.45 c over 1 minus 0.45 squared, because the c on the numerator and the c on the denominator cancel. You get something very close to 0.5039 mpc. Okay. Then you have your 0.85 c speed. And so your velocity will change here to 0.85 c. You divide that by square root 1 minus 0.85 squared. Again, the c's on the numerator and denominator cancel, and you get 1.6136 mpc. And similarly, for 0.95 c, I'm not going to work it out. You do the same stuff, and you get, except of course changing the speed, and you get 4.9247 mpc. Okay, so now you're armed with the 3 different momenta that you need, and all you have to do now is find the percentage changes, right? And so let's start with A. Remember, the percentage is given by a final value, so let's call it P final, minus the initial value, that's the difference, right? So this is the change in momentum, over the initial value, because you're computing the change with respect to the initial value, times 100, because we want it in a percent, right? And so from here, we have everything in units of MP times C, so that's great. And so for the first one, you want a percentage change from P.45 to 0.85. Okay, and initial is 0.45 times 100. And you already have everything in units of MP and C. So it's a simple arithmetic problem there. What you get is 220%. So this gives you something in percent. For part B, you have something very similar. This will be P.95 as you accelerate to 0.95 from 0.85 c, right, over 0.85, which is the initial one. Multiply that by 100, excuse me, and you get something like 205%. And so we can see that momentum changes by over twice as much in both cases. And that's it.